Let's take a look at number 4 from page 490. And as I work through that, hopefully it will make things a little more clear from this section. So looking at part A, we're supposed to find a 95% confidence interval for the difference of the real means, u1 minus u2. So that would be on page 460, because we know the standard deviations for both distributions. They were given to us in the problem. So we use the steps that start on page 459, but the steps for the confidence interval then are on page 460. So we need to find, again, that error of estimation, the large capital E. And if you're looking at page 460, the formula is you got to find a z sub c and then multiply it by that large square root with those things added together and squared underneath. So look at page 460 for that formula. You have all the data typed in here. I went ahead, and what you should do is figure out the squared values. So if you see on page 460 in that large formula, you need to square both standard deviations. So I squared the first one and the second one. And then I went ahead and computed the square root from that blue box separately. So the square root of the standard deviations divided by n1 plus standard deviation 2 squared divided by n2. So you get 0.86. And then to actually get E, as you see there, it says multiply that large square root by z sub c. And you have to look up what z sub c is for 95% confidence, and you look at table 3b and you get 1.96. So to figure out E, then you just do 1.96 times the value of that large square root that we figured out. So I did that here, 1.96 times the 0.86007. So you get 1.69, and that's our error of estimation. So you're going to add that to what you figured out here, which is, the two sample means, subtract them and see what you get. You get 3.6 when you do the first sample mean minus the second. So you're going to take 3.6 and add the error of estimation to get the upper bound, and then take 3.6 minus the error to get the lower bound. So again, the 3.6 will be right in the middle, but this is your confidence interval. We are 95% confident that the real average of subtracting the two means, u1 minus u2, we're 95% confident it's between these two numbers. So B says to examine that and explain what it means in the context of the problem. Well, see, it consists of numbers that are all positive. 1.91 to 5.29 are all positive numbers. So if you're subtracting 2 digits and you get a positive answer, it means the first thing you subtracted was larger. All right, just a quick example. If you're subtracting 2 things and you get a positive answer, like 3, it's because the first one's bigger. If you did a subtraction and you got a negative answer, it's because the first one is smaller. So because when we do, we're 95% confident that when we subtract it, we're going to get a positive answer between 1.91 and 5.29. That means we're 95% confident that the first number is bigger because we're getting a positive answer in our subtraction. So we are 95% confident that u1 minus u2 will be in this range, 0.91. So we are 95% confident that u1 is larger than u2. Or in the context of the problem, that would be the percentage of stockholder equity for retail stocks is higher or larger than it is for utility stocks. Okay. And then looking at part C there, where it says test the claim that the profit as a percentage of stockholder equity for retail stocks is higher than that for utility stocks, and it gives us the level of significance as 0.01. So that's the first part. Just note that the level of significance is 0.01. And our null hypothesis would be that utility and retail stocks both have the same level of equity. They're both equal. There's no difference. So we start off with the null hypothesis that they're the same. And now we're going to test that the theory that retail is actually bigger than utility. So U1 is actually larger than U2. For Z, first part 2 here, you got to find our Z value. And again, the steps are on page 460. We're using that blue box there on 460 because we know the 2 standard deviations. And you see, to figure out Z, you just have to do the difference of the means, which we already figured out, which is 3.6, and then divide by that same exact large square root. So that's why earlier I found the large square root and just did it separately, because I knew I was going to use it for both the confidence interval and to find the Z value. So back to where I was. So all I did there was take our difference of the 2 means, 3.6, and divide by that large square root. And what you get is for your Z value is 4.19. And you could look up normal Z values in the table in the back of the book, appendix table 3, but 4.19 is so far off the scale that you can't actually look it up. It's so small. You can also do them in Excel by using the normal distribution function, norm.dist. And I typed in 4.19, and then you type in 0 and 1 so that you're on the standard normal curve. And remember, Excel gives you the left tail values, but we're trying to look for U1 being greater or to the right of U2. So we're looking for right tail values. So we have to do 1 minus what we get when we use the normal distribution with 4.19. And let me undo that. So you get a really small number because it's very unlikely to get a Z value this large. The p-value probability is really small. And so since the probability is so small, it's less than 0.01, we're going to reject our null hypothesis. We don't think the means are equal. And conclusion, in the context of our problem, it just means that 1% level of significance, there's sufficient evidence to say that retail stocks actually have higher equity than utility stocks. They're not equal. So I hope that makes a little more sense. If you don't know the sigmas for the entire distribution, you just use the steps on page 463 and the student's t distribution. Most everything is exactly the same as the steps I outlined here. To figure out the error of estimation, you're still going to need to start with figuring out that large square root. And then you multiply, instead of multiplying by the Z sub C value, you have to look up the T sub C value. And your degrees of freedom, pick the smaller of the 2 values. So if we had to use the T distribution for this, 32 smaller, so we would use 31 degrees of freedom. That's how we do it without using really advanced software. So then you just find your T sub C value, you get your error of estimation, you add it, subtract it to the difference of the means, just like we did here, to get the lower and upper bound. And then for this part, it's the same with the T distribution as well. You're gonna, if you see there on page 464, you take the difference of the 2 sample means and divide by that large square root to get your T value. And then you proceed just like we did here. Convert the T value to P value and either reject or accept. So I hope that helps. It's great if you can get an idea of this stuff. It'll help you on a couple questions on the final, which I am counting as bonus since I did not assign 11. The 11 assignments were optional. But don't spend too much time worrying about mastering this topic if it takes away from you reviewing and refreshing on the other material because it is more important to do well on the final exam on all the other material than it is to learn chapter 10 and get these assignments in. So I hope it helped. Let me know if you have any questions.